Hello dear friends, this is Darpan and I welcome you into the tutorial of Fundamentals of Electrical Engineering. So this is the first lecture tutorial in the series of tutorial of Fundamentals of Electrical Engineering. So let's begin with our tutorial. So our first tutorial would be voltage regulator uh, or voltage controllers. So is there any difference between voltage regulator and voltage controller? Basically, yes, there exists a difference. So voltage regulator is something which regulates the voltage. Doesn't matter what is the input voltage, but I want my output voltage is fixed irrespective of the input voltage. That is what we call the regulated output voltage. But on the other hand, controllers are like you can control the voltage. Can you give me can we have an example of controllers? It's like a fan controller. Anytime we can adjust the voltage, and with that voltage we get the speed of fan. So this is what the voltage controller is. Voltage regulator is we get fixed voltage at the output. So let's see the block diagram of it, voltage regulator or voltage controller. So basically in the block there is a voltage regulator or converter. It may consist of various components. It may consist of a complex circuitry or very simple circuit as well, which takes the input voltage which may not be fixed and which may not be required. So it takes the input voltage and converts or change the level of voltage, and it gives the output voltage. So that is how it voltage regulator or voltage converter or controller it works. So one thing is, why do we require a regulator or converter? Where does it find its application? There are lots of application where voltage regulator and where voltage controllers find, like your mobile charger. Your mobile charger battery requires 3 to 5 volts of DC voltage, but in your household applications you are having 220 volt AC. It is not possible to fit 220 volt AC to your mobile, otherwise it will damage completely. So in that case you require some intermediate between 220 volt AC to some a very low or 3 to 5 volt DC that will convert your 220 volt AC to 5 volt DC that would be charging your mobile battery. So there are such kind of various application, like uh, you might have heard about some very local term adapter. Basically that is a converter, that is an AC to DC converter only. So that is, we in our local language we call it adapter. So there are many cases where we require the voltage conversion. So those things only we are going to learn in the basic in depth in details. So conversion can be of two types. One is DC to DC conversion, AC to AC conversion, AC to DC, DC to AC. That's fine. So, but in case of voltage regulators and voltage controller, right? You may want AC to AC conversion. Like I have 120 volt AC, 220 volt AC, but I want 20 volt AC only to supply my any device. So that is the AC to AC conversion. Like you just want to step down the level of voltage. And another is DC to DC converter. DC to DC conversion. I have a 12 volt of battery, but I want to supply a device whose requirement is 120 volt DC. So you need to step up the voltage, right? So in that case, we can have a application of step down DC voltage as well, right? So let's go to the next slide. Yeah, in this slide we are going to see the types of regulator. Basically, there are various types of regulator and controller or converters are available. So just let's see by one. So this is a very basic type of regulator. This is nothing, just a combination of two resistances connected in series. So when two resistors are connected in series and you apply input voltage across the combination of resistance, and you take output voltage across one of the resistor, here you apply input voltage and here you are applying the here you are tapping the output voltage. Wherever R2 is the variable resistance, you can vary the resistance. We will normally call it a potentiometer. So when you vary the output voltage, the expression of the output voltage is given as here. V out is equal to R2 upon R1 plus R2 into V in. This everyone you might have studied in your first or second semester of the electrical engineering. This is the voltage divider rule. This states that R1 plus R2 is always fixed. But when you change the R2, your output voltage also changes. Your input voltage is also fixed. As you R1 is fixed, when you change R2, your output voltage varies. So in this case, you can vary your output voltage if you have fixed input voltage, but you can you can't go V out more than V in. Maximum output voltage you can have is equal to the input voltage. Let's say you are giving here 10 volts, and you can get here maximum 10 volts. Maximum 10 volts. You can't get 12 volts if you are giving 10 volts. Your voltage divider rule, your voltage divider or voltage divider cannot step up the voltage. It will always step down the voltage, right? So in that case, the R2 should be open circuit if you want the same voltage, right? R2 should be open circuit. Normally we don't use this circuit in our daily life, potential divider, but at sometimes we use this as well. So where we use this and where we don't use this, because it has some limitations actually. I have listed out some limitations on the right hand side of the screen. You can see there. So one of the bigger limitation is the power loss. Resistance are known for the power loss. When you connect some voltage across the resistance, definitely they will consume some amount of power. Depending upon the value of resistance, how much power they will consume. So if you want to use the uh, potential divider circuit for a regulator, in that case you need to choose the value of R, that is the high value of resistance you need to select, so that the power loss is minimum. This potential divider circuit can be good to use as a voltage controller if power loss in the circuit is acceptable. If I have a input voltage signal is a quite lower, so that the power loss is also negligible, so in that case design may be acceptable. This is good for even milliwatt power applications or few watt power applications. Another thing is there, voltage regulation. See, when you see from the output side, this side, you definitely get required voltage of your choice, but at the same time you also see Thevenin's resistance, that is the internal resistance of the power circuit. It means that let's say I convert from 10 volt to 5 volt, but it will have some internal resistance. When I connect a load to circuit, the voltage across load won't be 5 volt, will not be 5 volt, it will be less than 5 volt. So some of the voltage has been dropped onto the internal resistance. So this is what it gives you a voltage regulation, that there would be voltage regulation, right? So to avoid voltage regulation, to minimize the voltage regulations, your resistance would be as minimum as possible. So what would happen if your resistance is as minimum as, power loss would increase. So if you want to compensate the power loss, your resistance should be high. If you want to compensate voltage regulation, minimize the voltage regulation, your resistance should be low. So what should you do actually? There should be trade-off between these two things as per the design. What is more acceptable to you? Second thing, next limitation, voltage is not regulated if input is varying. Let's say my requirement is 5 volt DC fixed constant. I don't want to vary the 5 volts at the output at any condition. And if I give here voltages, my voltage is varying from 10 volt to 15 volt, 10 volt to 15 volt, 12, 13, 14, 10, 12, 12, 13, 14, like that. So if my voltage is 10 volt, output is 10 volt, sorry 5 volt. But if my voltage increases, at the same proportion output also will increase. So I do not get my output regulated of 5 volt, right? So regulation is not possible in this case of potential divider networks. So another one advantage of this potential divider circuit is that these circuits are very cheaper. What cost is there? Nothing. You just need to buy few resistors only, and the resistors do not cost much. So if your design is acceptable for the power loss or voltage regulation, you may go for the potential divider circuit. And if there is no requirement of regulated supply, regulated voltage, you can go for this potential divider network. Let's go on to the next slide. In next slide you will see this is for the DC, right? Even you can supply AC also. Same will work for AC as well. 25 volt AC, I want 5 volt AC outside. at the output. Yes, this is also applicable, but again same power loss voltage regulation would be there. Can I do something to avoid the power loss? Yes, that we will see next slide. For AC, use capacitor and inductor C and L. Why? Because capacitor and inductor never consume any power. They store the power, they store the energy in one cycle, and they give back energy to the source in another cycle. They never consume power. So that's why you can use a capacitor potential divider or inductor potential divider. So the output of the capacitor potential divider will be C1 upon C1, C1 upon C1 plus C2 into input voltage. Higher the C1, more the output voltage. But in case of resistor, it was R2 upon R1 plus R2. Higher the R2, more the input voltage. Right? Second thing, V out in case of inductor potential divider, L2 upon L1 plus L2 into V in. So potential divider formulas are same for resistance and inductance, but some slightly different in case of capacitor potential divider. Right? Now one question, can I use inductor and capacitor in DC? You cannot use inductor in DC because inductor will act as a short circuit. Inductor won't work at DC. But you can use the capacitance in capacitor potential divider in DC. But in that case, you need to see the internal resistance of sources. If your source is having internal resistance, there will be a concept of time constant in the circuit. So if you take care of these things, you can use the capacitor potential divider in DC. You can always use RLC in AC circuit potential divider. There is no issue of power loss, but still there is a issue of voltage regulation in this. Coming to the next slide. Okay, so again voltage is not regulated here. If input voltage increases, output voltage also increases. So what we can do for to get the regulated voltage? I want output voltage regulated at 5 volt. Doesn't matter what my input is, right? So let's see. Let's jump into the next slide. You can use 78XX series. This is a series of IC that is produced by manufacturer. So here XX stands for the various voltage levels. When you say 7805 means it will give you 5 volts regulated voltage. 7806 it will give you 6 volt 0. When I say 7818 it will give me 18 volt unregulated voltage. Right? So basically this is a 3-terminal IC. One terminal input terminal, one is the output terminal, and another is ground terminal. You give input voltage and you get output voltage. You give input voltage with respect to ground. Here you connect the input voltage with respect to ground. This is the input voltage I am connecting with respect to ground, and I am observing again output voltage with respect to ground. Ground would be my common point actually from my input and output reference. Like, so I give some voltage at the input side and I get some voltage at the output side that is regulated. But there is one condition actually. One condition always need to be fulfilled to get some fixed voltage regulated at the output side. What is that condition? Input voltage must be 1.5 times of the output regulated voltage. It means what? Let's say if I want 10 volts regulated voltage, my input should be at least 1.5 times of 10, that is the 15 volt. If I give at least 15 volt at the input, my 7810 IC would work satisfactorily. If I give the voltage less than the minimum voltage, so for 10 volt minimum input voltage is 15 volts. If I give less than 15 volts, this IC won't work this IC won't work properly. You may not get regulated voltage of 10 volts. If you decrease the voltage less than 15 volt in input, you may get output voltage less than 10 volts. So again you are not getting regulated voltage here in the output side, right? So input voltage must be at least 1.5 times of regulated voltage, right? So this is the one of the most popular series, 78XX series. This will give you positive voltage at the output side. There is another series also known as 79XX series. When you go for 79XX series, right, it will give you negative voltage like 7905. That will give you minus 5 volts with respect to ground, right? For that input voltage requirement is also negative. So this is the 78xx series. Now see, for the 10 volt, for 5 volt, I should give minimum 7.5 volt for 5 volt regulated voltage. What is the maximum voltage can I give to the input? Is it like 20 volt, 30 volt, 40 volt, 50 volt, 100 volt? It is not possible, right? Because maximum voltage details are also, that would be a maximum limited voltage. So those things will be mentioned in the data sheet of the IC. I would recommend one must go through all the specification in the data sheet before using an IC. So far we have seen two types of voltage controller or regulator, you say, but we will go in some problem. We will go through one problem in next slide. So see, my requirement is convert 50 volt DC into 5 volt bipolar power source which provides regulated voltage. This is 50 volt to 5 volt DC, 50 volt DC to 5 volt DC, that is bipolar power source. Bipolar means positive and negative with respect to ground. That is what the power bipolar means. How to do? Pause this video and think, right? And then if you get your answer, go to unpause your video and see. Step 1, just gather your requirements, what all things you need to do. You will need to require 7805 and 7905 voltage. 7805, why? You will need to regulate 5 volt positive, you will need to regulate 5 volt negative, so that you require 7905. Use the below URL to get the data sheet of the IC, both the ICs. Another thing, if I am going to use 7805 or 7905, I need to give at least 1.5 times of voltage, that is 7.5 at least. But at the same time, my data sheet says that I should not give more than 30 volt at the input side for 7805. So I should not give more than 30 volt. So means my input voltage is 50 volt, I need to take care of the input voltage given to the IC. So I need to step down some voltages. So what I need to do, I will be using capacitor to reduce the input voltage. How? See, this is the capacitance series network I have used here. 50 volt DC. I would be taking voltage across C1 and C3. So I have selected the capacitor in such a way that the voltage across C1 is 20 volt. Voltage across C2 is 20 volt. Voltage across C3 is also 20 volt. I have selected the midpoint is a ground point, or I assume this point is a reference. So this point is as a VC2 will give me plus 20 volt with respect to 0 volt, and VC3 will give me minus 20 volt with respect to 0 volt. You can calculate VC2 with this formula, C1 C3 upon sigma C1 C2, where sigma C1 C2 is C1 C2 plus C2 C3 plus C3 C1. Same here as well. You can calculate VC3 with this formula. Right? In this way we got plus 20 volt with respect to ground, minus 20 volt with respect to ground. So this is, I have drawn the equivalent diagram of output voltage. I have received with the potential divider circuit, I have got 20 volt with respect to ground, minus 20 volt with respect to ground, and this is my ground. Now next, what I have to do, I have to connect 7805 at the 20 volt and 7905 at the minus 20 volt. See, this is I have done. Plus 20 volt I have connected to 7805 input, minus 20 volt I have connected to 7905 input. Ground point is connected, ground point of one IC is connected to the common 0 volt. Ground point of 7905 is connected to 0 volt, and I am taking output from 7805. This will give me 5 volt with respect to this point, with respect to 0 point, and the 7905 will give me minus 5 volt with respect to this point. So again I have got my bipolar supply, bipolar power supply. This is 5 volt, this is minus 5 volt, right? 5 volt with respect to ground point, 5 volt with respect to this ground point. So the net voltage is 20 volt, 10 volt, plus 5 minus 5. This will give me 10 volt. So this is how we obtained our bipolar power supply of 5 volt. So thanks everyone for watching this video. Thank you.